Good morning, everybody. I just wanted to do our lesson for 10.1. This is going to be for volume of rectangular prisms and rectangular pyramids. Okay, so we'll do triangular prisms and pyramids next. That'll be in lesson 10.2. But the big thing that we have to know is our formula, and we have to know how to use it. If you understand the formula and how to use it, you're going to do just fine on this. So it says, our rectangular prism is found by doing length times width times height. That's right there, length times width times height. The reason it is that is because you find length times width to find the area of a rectangle. Well, you multiply it by the height, that will give you the volume of the entire shape. So the formula that we see on our formula chart is volume equals big B times H, whereas big B equals the area of the base. So if you have a rectangular prism, you're going to find the area of a rectangle and then multiply that by the height. So let's go ahead and get into some examples so you can get some extra work on this. For example 1, it says find the volume of the rectangular prism. So we find the area of the base, which is length times width. So here's our base. Length times width, so we have 12 times 15, and that's going to give us 180. Well, then we multiply that by our height. The height is your distance between your two bases. So in this case, our height is 7. So we'll do 180 times 7, and that will give us 1,260 cubic millimeters. So the volume of our rectangular prism is 1,260 cubic millimeters. Volume is always cubed. Okay, so up here on your paper, you might want to write always cubic units. So to the third power, so like centimeters cubed, inches cubed, feet cubed. Okay, so make sure you're writing to the third power for cubed. So let's go ahead and flip it over. And you've got a reflection question. So go ahead and pause your video and do the reflect and the your turn. And then when you come back, your answers will be here. Okay, so our reflect says, what if? If you know the volume and the height, would you be able to find the area of the base? All you would have to do is divide the volume by the height. That's it. So divide the volume by the height. Because if we have V equals big B times H, if we're looking for the big B, remember all we have to do is divide both sides by the height to get the B by itself. Those are going to cancel, and then we get big B equals volume divided by height. Okay, so solving just like a regular equation. And on the your turn, we're using big B times H. Our gift box is 3.5 inches high by 7 inches long by 6 inches wide. So all you have to do is 3.5 times 7 times 6, and that's going to equal 147 cubic inches. Okay, so in this activity, we're just going to kind of read through it. Okay. So it says a net is a two-dimensional pattern of a shape that can be folded in a three-dimensional figure. The shapes in the net become the faces of the three-dimensional figure. We've worked with nets before, so this should be familiar. It says copy net A and net B onto graph paper and cut them along the blue lines. One of these nets can be folded along the black lines to make a cube. Which net will not make a cube? Okay, we're not going to actually do the activity, so don't worry about it. We're going to look at it, though. You're going to be able to visualize this. And because we've already done our work with nets, you should be able to look at this and say, okay, well, I can fold this one up and I'll get 4 faces. Fold this one over, I get a base. Fold this one over, I get a base. So this one looks good. Net A looks good. This one we can also fold up and we get 4 faces. We get our 4 sides. But when we fold these sides over, they're going to overlap. So we wouldn't have either a top or bottom. So net B is the one that will not make a cube. So on here it says, see if you can find another net that can be folded into a cube. I'm just going to give you a couple of sample answers of what they could look like. You could do, let's see here, if I can draw this very good without messing it up too bad, my horrible art. Alright, so we got 1, 2, 3. That looks pretty even. So these would be your faces, and then you could do 1 over here, and 1 over here. And when you fold that up, that would make a net. Another example that you could do, again, we need 4 all the way down, because we have a cube, so we need 4 faces. And then we could put 1 here and 1 here to make our bases. Now please ignore the fact that my boxes in this one are not all that even. Your cube should have equal sides, okay? So it just says compare your results with several of your classmates. Don't worry about it. Again, remember, we're not doing the actual activity. We're just going to kind of read through it and talk about it a little bit. So do your reflection question. Okay, number 3 says, what shapes will appear in a net for a rectangular prism that is not a cube? How many of these shapes will be there? Okay, so then do 4, 5, and 6, and then whenever you come back, we'll go over your answers. So go ahead and pause now. Alright, so what shapes appear in a net for a rectangular prism? Rectangles appear. Rectangles. Oops. And there are 6 of them. That's how many there will be. This one cannot be folded into a net because it only has 5 sides. Only has 5 faces. And a cube has 6. This one would fold into more like a loop. It wouldn't have any bases. This one would would have no bases. And then number 6, if you draw a net for a cylinder, such as a soup can, how many two-dimensional geometric shapes would this net have? Name the shapes. Well, a cylinder has 2 shapes. You have 2 circular bases and 1 rectangular face. Alright, so now let's look at some volume of rectangular pyramids. Okay, a pyramid is going to be a 3-dimensional shape whose base is a polygon, remember, a closed figure, and whose other faces are all triangles. Like a prism, a pyramid is named by the shape of its base. All of our 3-dimensional figures are pretty much named for the shape of their base. So if we have a rectagonal base, we're going to have a rectangular pyramid. Rectangular pyramid. If we have a triangular base, we're going to have a triangular pyramid. We have a pentagon as our base. We're going to have a pentagonal pyramid. If we have a square base, we're going to have a square pyramid. So what I find helps me in all of this 3-dimensional stuff, because sometimes all these lines kind of start to run together, is I'll shade my bases. That way I kind of see it a little better, and it makes it easier for me to find all my pieces. Remember, you have markers and you have matte pencils in the boxes. You could also use highlighters or pencils or whatever you have, because it kind of makes that base pop, so it makes it easier to see what it is. So the faces of a pyramid that are not the base have a common vertex. Okay, this is our common vertex right up here, where it kind of comes to a point. The perpendicular distance from the vertex to the base is the height. So from the vertex straight down to your base, straight down, is going to be your height. So let's put this into action. We again are not going to do this one because we're not going to have time. We might have time like towards the end of the week, but I'm just not sure. We can try to make some models, and what we're going to do is we're going to fill them up with, we used beans last year. So whenever we create our cups, what you're going to find is that a pyramid is actually 1/3 of a prism. Okay, so a pyramid is always 1/3 of a prism. It says how many times do you fill the prism? It would be 3 times. So we're just kind of skimming over this, but if you want to fill it in. So what we can draw from our conclusion is that if we do big B times H for a rectangular prism, we would do volume equals 1/3 of big B times H for volume of a pyramid. Okay, remember pyramids come to a point, so 1/3 big B times H is going to be our formula. The next question says, the prism and the pyramid in this activity have congruent bases and equal heights. Are they congruent three-dimensional shapes? Explain. They are not congruent. They absolutely are not congruent. They're not congruent because they're different shapes. In order for something to be congruent, they have to be exactly the same. So even though their bases are congruent, that doesn't mean the entire shape is congruent. A rectangular prism is not the same thing. It is not congruent to a rectangular pyramid. They just aren't. Alright, so try the year term. It says the volume of a rectangular prism is 4.5 inches, or cubic inches. What is the volume of a rectangular pyramid with a congruent base and the same height? Explain your reasoning. Okay, so try to work this out. This is a little tricky. You've got to do a little bit of work on it to figure it out. When you come back, check your answer and see if it matches up. Okay, when you solve it, you should get 1.5 cubic inches because, I'm just going to abbreviate here, because your volume is 1/3 of the prism. Is 1/3 of the prism. Okay? So if our prism is 4.5, our pyramid with the same height and same base is going to be 1.5, because 1.5 is 1/3 of 4.5. Excuse me. If you divide 4.5 by 3, then you'll get 1.5. It does work out. Hopefully you did it. Alright, so last little section of work here before you get to do your guided practice. So, solving volume problems. We're going to work an example together. It says you can use the formula for the volume of a rectangular prism and the volume of a rectangular pyramid to solve problems. So, the volume of a pyramid is 1/3 the area of its base times height. So, remember, 1/3 of big B times H. In our example, it says Kyle needs to build a crate in the shape of a rectangular prism. The crate must have a volume of 38.5 cubic feet and a base area of 15 2/5 square feet. Find the height of a crate. Alright, so we're going to write our formula. We have a prism, okay, keyword prism. So we're doing volume equals big B times H. So we get 38.5 equals, and we plug in big B as 15 2/5 times H. So I would do the same thing they did here. I would convert it to an improper fraction so it's easier to deal with. So we have 77/2 equals 77/5. Well, we're solving for H. We're solving for H. So we're going to multiply by the reciprocal, which is also dividing. This is just a different way of showing dividing both sides by 77/5. Okay, you would do, let me show you another way over here. 77/2 equals 77/5 times H. How do we get rid of multiplying? We divide. So you would divide this side by 77/5 so that those cancel, and divide this side by 77/5. The key is, and what a lot of people forget, is that when we're dividing, we do keep, change, flip. Remember KCF? KCF. We keep the first number the same, change our division to multiplication, and flip the second fraction. So I'm going to come over here where I have some more work, and if we have 77/2 divided by 77/5, that means we're going to keep 77/2, change our division to multiplication, and flip our second fraction, so 5/77. And that's exactly what they've done here. Okay, that's what this step is. It's dividing by 77/5, but when you do keep, change, flip, you're actually multiplying by 5/77. Alright, so when you simplify these out, these two are going to cancel out, and you're going to end up getting 5/2.